Now if we go down to the bottom of the mountain, if you've ever looked from the north along the front of the mountain, sort of towards the towers, you see this very nice uniform slope down the front of the mountain. And it has an angle of about 27 degrees. And I can go everywhere around Mount Dandenong, I will not find a slope steeper than about 27 degrees. Right? If I have the creek out here, Olinda Creek is not Olinda Gorge. If I go to other parts of Melbourne, we have steep-sided slopes, we have Werribee Gorge, say, Plenty Gorge. We don't have that in the Dandenongs, we don't have it in Mount Dandenong, because we have this very unique rock type rhyodacite, which erupted from a volcano 300 million years ago with a whole bunch of energy, but we really only have it in this area. It is a rock that is problematic for slope stability though. Over the rock, over geological time, we form clay. And you would have seen this reddish colour clay. Here's my little pencil diagram. Oh, there it is, my little pencil diagram.
If you just click that, it'll take you to the next slide.
Sorry, I'm moving around too much for our videographer. Here we go. So then,
Can't see it. Oh, sorry.
there we go. So I drew some nice pictures for you. We've got that red clay, and again, you would see that in the road cuttings. You'll see that if you've dug on your site, this nice reddish coloured clay. And as you dig down into that, you start getting little bits of rock, and then you dig down a bit more, and you find a bit more rock and a bit more rock. Now, the issue we have is that clay, and when it's rock, it can be nice and stable, but that clay can be unstable. If you go to the beach and you make a sandcastle, you can make a sandcastle with moist sand. It's what we call partially saturated. You can't make a sandcastle with dry sand, it's going to fall apart. You can't make a sandcastle with wet sand, and wet sand's just going to flow. You need it to be partially saturated. Partially saturated gives it strength. If we lose the partial saturation, we lose the strength and we get landslides. Now this material will stand, this clay, this residual rhyodacite we call it, will stand vertical for decades. Road batters that have been cut up here in the late 1800s, they're still there. It'll stand there for decades until it loses the partial saturation, until it gets wet. And when it gets wet, then we get landslides. And managing landslides is all about two things. We don't want the ground to be saturated, first thing, and we don't want it to be steeper than that angle, 26 degrees, which is the long-term stable angle that we see up in the hills. And those are the two key things we do to manage landslide. The slope angle, we keep it less than 26 degrees, and we keep the soil, we don't let the soil get saturated. That's what we need to do. Now, with the storms, we've changed things. We've had vegetation come out. Now, vegetation keeps the ground partially saturated because of evapotranspiration, because of bringing the water out. And we've lost trees. We've also put minor earthworks in, tracks have come in to give access to machines. Water is flowing in different places. So what that means is we've got a risk that we saturate ground that hasn't been saturated for a long time. I heard some good points. We had a bunch of landslides up here in Kalorama in the 30s. We had some in the 50s. We've had some smaller ones in the 80s. But since then, since the planning controls came in sort of the 90s, it's been pretty good. And most of the failures, and if you've lived up here long enough, you'll have come out on after a wet night and road batters have come down and rocks come down. That's most of where we have the problems now, because we've got good planning controls. We've got to keep it that way. But because of the storms, we're more vulnerable to instability. We're more vulnerable in some areas to the ground becoming saturated. And another point I heard, in the 70s and early on, we just cut in and put cuts and fills and with a little bit of abandon, and they are now vulnerable, or perhaps more vulnerable than they would have been before. So, sort of thing, I've got a few examples. This is one from, this is in the 90s, actually early 90s. It's a poor fill. somebody's got a bad fill up on above their house, it's got wet and it's very sensitive, and it's saturated down, and there was a girl in the backyard there, I understand having a clandestine cigarette, a teenage girl, and the soils come down, and she was lucky to survive that one. That was probably one of the closest fatalities we've had in Yarra Ranges. But it was poor building and poor planning and an inappropriate place to put a steep fill embankment. These are some of the recent ones that have happened just since the storm. This might be Woodhurst, Max. Yeah. And that's sort of a small thing, it's just slumped out. Water's got on there, it's slumped out. This is the sort of thing we might have. Now, that's on a road, we cleaned it up, you don't want that behind your house. Sorry, it's all over the place, I'm sorry.
No, you're doing really well.
Keep pressing
My
the button.
mouse is super.
It's very sensitive, but that's all right.
I'll grab the mouse and you just tell me next. I'll take it through.
I'll go up to the second one. The second one, I just want to show another example there. This is just another example of, vegetation lost. You've got where this is actually over in Upper Factory Gully, and it's slid out. And this is the sort of hazard that we're currently facing. And we want to try to do what we can to avoid this hazard. We don't want that. You don't want that in your backyard. You don't want that affecting your new house. And so, what do we do about it? Let's go to the next slide. I thought I'd first show you what not to do about it. Yeah, this one here. So let's have a look at what's going on here. There's a house on the left. I won't say where this one is. There's a house on the left, and that's about a 3 metre high, steep cut right behind it. If that cut gets wet, it will come down. It's not it might, it will. One of the things I often hear is, oh, well, that cutting's been there for 30 years and I've never had a problem, and what are you talking about? But the science tells us that just means it hasn't got wet in 30 years. If it gets saturated, it comes down. Then you've got this retaining wall up in the mid-slope, leaning out, probably not properly engineered. And here we have at the top a water tank sitting on what looks like fairly loose fill right above the house. These are the things we're trying to avoid. So as a general principle in your development, there's a couple of points I sort of want to get across. You may have earthworks existing on your site that were put in before the planning controls that are potentially unsafe. If they are steeper than that 2:1, if they don't have a retaining wall, and if they're higher than about, say, 1.5 metres, they're potentially unsafe. Right? And that 1.5 metres, we've got a metre in the planning control, that's similar to, say, WorkSafe guidelines. You wouldn't be allowed on any construction site in Melbourne to have an unsupported excavation higher than 1.5 metres. Right, so why would you have it in your house? So that means it's potentially unsafe. And some of you now have an opportunity, if you have that condition on your site, to address that issue. And that's usually going to mean constructing retaining walls, or reducing the angle of it, or putting in drainage to prevent it from getting saturated. So those are the things we need to do going forward. Now, when you put in your application at step 4, your geotechnical assessment at step 4, your geotechnical engineer will come to the site, he will look for these hazards, he or she will look for these hazards, and they should advise you on how to address them. And that is why we have that in the planning process, in the planning scheme. And we mentioned vegetation. For landslide, as much vegetation as we can have is better, we want that, but we recognise the conflict with the bushfire risk. But if we have to clear vegetation, we can supplement that with good drainage. Drainage can also help keep our ground wet, prevent water from ponding. If we've got tanks, we have drainage underneath it so it drains out, not drains in. Right? We don't allow water concentration flowing off roads to come down and concentrate on a particular spot. So we try to avoid water concentration into the ground. So I hope as you go forward, these are some of the things you'll think about from the landslide and slippage and erosion aspects.